then I think I'm going to ask the same question to Iustus at the end. Okay, please, you share your slides.
Okay, thank you for the introduction. I'm quite excited about hearing the previous talk by Ivano, who's sitting right next to me. Mine is going to be about a similar institution, but there are also some striking differences. So I'm the founding director of the Digital Science Center at the University of Innsbruck, which was founded a little more than 2 years ago, about 2.5 years ago. Let me start with a little bit of motivation. Digital methods permeate our lives, both at the university, in research, and in everyday life. Here are some examples from the press and from your personal lives. For example, a few years ago, the AlphaGo system went through the press when the world's best Go player was an AI system for the first time in history, after sort of this game being elusive to computational methods for decades. So that was quite a breakthrough that was part of the game changers that brought AI back onto the stage. Or face detection systems are in everybody's smartphones. Everybody's familiar with those. Or photo organizing systems or Facebook systems can label all your pictures with the names of your friends automatically or reliably. So that's AI technology in everyday life. Another example, YouTube's recommendation system. Recommendation systems are everywhere with all the pros and cons, and we've heard a lot of talks about those today here at this conference already. Or another example, the automatic spelling correction and suggestion system on your smartphones. As you type, the system will suggest corrections of what you're typing, and will actually suggest entire words or the next word as well. But that when I type a message, I really have to consciously force myself to type what I really want to type and not what the system wants to make me type. So these systems are really everywhere and quite intrusive also in our lives. But it's not only in these systems, but digitalization is also pervasive in research, and disciplines that historically don't have a lot of connection to digital methods nowadays cannot do their work without digital technologies. And at the same time, in many such disciplines, there's no systematic training in digital methods for researchers. So there's a disconnect between the realities and demands of the type of research that is going on the one hand, and the systematic training on the other hand. And this is the key reason why my university founded the Digital Science Center. The goals are to support the digitalization of science and research at the university, and in this way, at the same time, boost the quality of science and research that is taking place. And also, we want to foster interdisciplinary synergies, in the sense, for example, that similar techniques of data analysis, machine learning, and artificial intelligence are used across different disciplines, which allows us to work together on different projects using similar methods, and conversely on the same problems using different methods from an interdisciplinary perspective. And to implement this agenda, the university created 15 roughly new tenure-track faculty positions of diverse disciplines. And these are researchers that are at home both at the Digital Science Center and at their respective home faculties. So the Digital Science Center is an organizational unit, the first of its kind at our university, outside of the faculty hierarchy, and It reports directly to the rectorate, and all of these researchers, all our staff, are 50% affiliated with the Digital Science Center and 50% with the respective home faculty. And it's beyond that intended to serve as a platform for communication and collaboration within the university. And we also organize our own teaching portfolio, which includes digital methods for various disciplines. So I just want to give a few examples of researchers at the Digital Science Center and the kind of research that they do. Here we see Retrieval Stauffer. He is an atmospheric scientist and statistician, and he works on refinement of weather forecasts using statistical methods. The problem with weather forecasts is that they're based on computational models that subdivide the atmosphere into cells, and these are very many cells. And if the cells are too coarse, then you cannot get accurate forecasts, and if the cells are too fine, then the computation becomes so complex that the forecast arrives after the actual weather, so that it's kind of useless by then. And the way to solve that is to work with multiple resolutions, or in his case, to locally refine the forecasts based on local statistics. So if you compare the forecast to the actual developments of the weather, then you will observe systematic differences. And these systematic differences depend on things like the local topography, which is quite complicated. And so what we see here is Tyrol, where I live and work. And the granularity of common weather forecast is way too coarse to take account of all the valleys and ridges that exist. And Retrieval Stauffer develops methods that take these topographical and other characteristics into account to learn how the local weather deviates systematically from the forecasts as a function of these local specificities. And in this way, he can obtain very high resolution improvements to the forecasts. So this is an example that everybody can always relate to, I guess. A second researcher is Gabriel Rojas Kopeinig. He is a physicist and civil engineer, and he looks into the quality of indoor air. And there are different factors that enter into the equation, including most importantly, the composition of all kinds of components that are floating around in the air, the mix of the different gases and so on. And he develops digital models for the optimization of indoor air quality and at the same time energy consumption. So this is also a very important aspect of research that directly contributes to sustainable development goals. Another example, this is Miguel Rodriguez Rojas. He is a microbiologist, and he develops digital methods that allow him to analyze the ecology of microbial communities. He works with metagenomes, which means that he doesn't grow samples in the lab and then analyzes the genomes, but he goes out into nature or has other people go out into nature and collect samples directly from the ground. And here's an example that already dates back a few years. We looked at microbial communities in Lake Lanier in northern Georgia in the US, where he lived and worked before he came over and joined our Digital Science Center. And he analyzed the genomic variations in this lake, both over time and then also over space, as these microbial populations are spilled down the Chattahoochee River and ultimately into the Gulf of Mexico. And we learned that along this river, the microbial genomes changed slightly, and by the time the river arrives at the Gulf of Mexico, there's only very little similarity to the microbes in the lake upstream. Another finding was that the microbes form stable families. There's not a continuum of changes in the genome, but they tend to be stable, more or less stable subcommunities. Yet another example, completely different. Joseph Wang Katrein is a philosopher, and like his predecessors in this presentation, he developed software. So all these people develop their own software, which is why they're specialists of the kind that we hire at the Digital Science Center. They're not only experts in their respective disciplines, but also in the digital methods. And the software developed, they make accessible to the community at large, which makes them quite visible in their community. So this is true in particular of Miguel from the previous example, and Joseph. They both make the software available, which is then used by large communities. So Joseph Wang looks into material from the Brenner archive in Innsbruck, which is home to many materials written by Ludwig Wittgenstein. And these are manuscripts that are difficult to read, even if you have it on paper, and you want to make these data available for automated analysis. So there's an entire pipeline from digitization of the manuscripts in various stages to make them available in a form that is machine readable and also more easily readable by humans. So Joseph develops data models and develops software for analyzing the data and transforming the data and analyzing the data, which involves programming, of course. And then one target is, as we see here on the bottom left, the provision of the results on a website, both for humans and for machines to read. So philosophy these days is no longer done at the desk with people using pencils to mark what they read, but there's a lot of quantitative analysis, including questions such as how did the writing style change over time? Are the text passages that were written by other authors, maybe scholars, because they differ in the vocabulary that they use and so on. Our next example is Matteo Saviano. He is a roboticist, and he works 50% at the Digital Science Center and the other 50% in my research group at the Department of Computer Science. So in a way, I'm his double boss in both of his affiliations. And he is interested in teaching robots to do various things. And teaching is can be taken quite literally. We want the robot to execute a plan. And instead of programming the plan, as is done these days in industrial robotics, we want to be able to do this in much simpler ways by having humans demonstrate to the robot what to do. So there's been a lot of research in this area that was done for decades. And what he's specifically interested in is analyzing these demonstrations automatically, chopping them up into individual units that can be recombined and reused depending on novel tasks that the robot encounters, such that the robot develops an entire library of skills that can be automatically reused, and the robot will then require novel demonstrations only when a situation arises that is so different from what it's seen before that it requires a new demonstration, which will then again be added to the library in order to become increasingly autonomous over time. Then I could talk about novel information retrieval and knowledge discovery approaches for archival news collections by Adam Jartoft, who is the only full professor at the Digital Science Center. But I'm going to skip this because he gave an entire talk about that topic himself earlier today. And finally, we're not only looking at technological solutions to problems in science, but also at problems that are produced or issues that arise due to the application of digital methods. We're looking into societal questions such as questions around data collection. We all like the personal services on the web that are powered by the data that we hand over to the service providers. But with the data, we also give up some of our rights and freedoms. And we've heard quite a number of talks today already that were concerned with these questions. Or also, how do we consume news? So in early days, we read news in papers and watched them on TV. And now many people don't do that at all anymore. They just entirely rely on the news feeds provided by online services. And that also has its pros and cons. You get news that are interesting to you, but at the same time, maybe it locks you into a bubble, or some of these news carry little value, but they raise emotions, or they are even nefarious in the sense that they carry misinformation, or they distract from issues that are really going on. Another typical question: do digital means destroy jobs at large scale? Automation, for example, or the other ways that data are analyzed automatically. And if you look at the statistics, generally the answer is no, but of course these digital means do change the occupational landscape, and this quite dramatically, depending on the area of the economy that we're looking at. And there are different people at the Digital Science Center who are looking into these methods. For example, Clara Rauchegger, who is a law expert specializing in digital society, and also Alexander Kupfer, who is an expert at digital business and looks at digital business models and the influence on society. Then I want to say just a little bit about the teaching done by the Digital Science Center, which is mostly concentrated into the academic minor digital science, which is open to students of all subjects at the entire university. And the idea is to equip them with the basic knowledge they need, the basic skills they need to understand and apply digital methods with an eye on their own academic discipline. So at the beginning, there's an introduction to programming, because most are, of course, not computer scientists, and also data management. How do we manage data? How do we work with data? How can we phrase questions by way of programming? And the next block is data analysis. Of programming, we do this in both R and Python, so there's a choice between those. And then they learn how to analyze data using computational means. And finally, well, not quite finally yet, there's aspects of digitalization which looks at societal aspects of law and economy. So these are non-technical aspects of digital science that are important. And in the data analysis lab, they apply what they've learned to a question of their choice, which will generally be a question of their own subject discipline. So this is the teaching side of the introduction of competence in digital methods that the Digital Science Center was founded to convey. And with this, I would like to end. If you are interested, you can check the website of the Digital Science Center, where you will find a description of the goals and means, profiles of all the members of the Digital Science Center, and also information that I did not talk about, including events that we organize, including research gatherings and presentations that are targeted primarily at the scientific community, mostly within the University of Innsbruck, but also presentations using high profile outside speakers that are addressed at society at large.
Okay, thank you very much. Questions, remarks? What I observed is it seems that the focus of your interdisciplinary research is the introduction of digital methods or the innovation with digital methods in different academic fields.
Yes.
Today we had a lot of talks on regulatory issues, political issues, social issues, ethical issues. You told that there is some research on it, but is that also in the education which are involved in the list, in the amount of is there? So is this correct, this observation, that this focuses on digital methods introduction, and what are you doing with, let's say, the societal aspects of the manifesto digital that you will be used in your society?
Yes, that's correct. The focus is on digital methods, and most of the research at the Digital Science Center and also most of the teaching focuses on competence with digital methods and the application to questions of research problems that they want to be solved, or that they want to solve. But then at the same time, there's also the area of societal questions, which enters into both the research side and the teaching side. So we're also looking into the effects of digital methods on society, which is the core of the research of two of our members at the Digital Science Center, and which is also the content of the fourth block here, aspects of digitalization in our teaching portfolio.
Okay, that's very useful. Well, thank you. Are there any other points people want to raise? If not, I would like to close this session for today. I wish everyone a good evening. Tomorrow we reconvene and open at 8:45. At 9 we will have the Untitled Chapter by Sally Wyatt, who is a digital society researcher herself. But what is also interesting, she has been coordinating digital society bachelor, more from the humanities, arts and social science faculty. That is already running. I think her experiences with this digital society interdisciplinary education are also very useful for us and all but that will be 8:45.